Irrigation is an age-old art and is defined as the application of supplemental water to a soil for plant growth. It also provides a mechanism for nutrients to move from the soil into a plant. Other uses include salt leaching, fumigation, system flushing, seed germination, and climate modification. On average, Florida receives more than 50 inches of rain per year. However, the distribution and amounts of this rainfall are not always adequate to meet a plant's water demands. Providing the amount of water that a plant needs at the correct time is the key to resource conservation, reduced pollutant loading, and optimum plant growth. I'm Dr. DeBusk, and this video describes irrigation concepts to help explain the fundamentals of good irrigation. In addition, this video identifies specific irrigation BMPs for the green industry. Throughout the video, the term plant refers to both turf and landscape plants, including trees. Green industry workers need to be aware of the different irrigation processes and system components because irrigation is a major factor in the success of their industry. By understanding the irrigation system, they can save the company and the client money and help protect groundwater supplies and water quality. This section of the video includes background information and irrigation BMPs for the green industry. Some of the BMPs mentioned are not usually considered the responsibility of mowing and trimming services or route-based service businesses. However, many green industry workers who may be directly employed by property owners, associations, or municipalities are often responsible for operation and maintenance of an irrigation system. For complete BMPs specific to irrigation, please refer to the Florida Irrigation Society, the Irrigation Association, and the University of Florida's Institute of Food and Agricultural Sciences, UFIFAS. Many agencies have jurisdiction over an irrigation project before, during, and after construction. For example, Florida's 5 water management districts, Florida Department of Health, Florida Department of Environmental Protection, or local governments may require well permits. Typically, for large projects, the water management districts issue water use permits, which are usually calculated for drought conditions rather than for normal irrigation. To prevent potential fines, it is important to identify and abide by all regulatory requirements. Besides water use permits, some water management districts have special year-round water conservation measures and drought water shortage restrictions that govern the amount and timing of irrigation. It is important to know the restrictions for a site and to set timers and controllers to those conditions. Since water shortage restrictions change with the severity of a drought, it is important to be aware of and to abide by current restrictions. If a site's irrigation system cannot be adjusted to meet the restrictions, the system should be upgraded as soon as possible. But in the interim, there are methods to obtain variances. These variances need to be obtained in writing before irrigating. Florida law requires the operating moisture cutoff device on all automatic controlled irrigation systems. In 2009, this was revised and mandates owners and contractors to maintain these systems. Any person who purchases and installs an automatic landscape irrigation system must properly install, maintain, and operate technology that inhibits or interrupts operation of the system during periods of sufficient moisture. A licensed contractor who installs or performs work on an automatic landscape irrigation system must test for the correct operation of each inhibiting or interrupting device or switch on that system. If the devices or switches are not installed in the system, or are not in proper operating condition, the contractor must install new ones or repair the existing ones and confirm that each device or switch is in proper operating condition before completing other work on the system. The following permitting and regulatory guidelines should be followed for all irrigation projects. Contact local and state regulatory agencies such as the county, city, Florida Department of Environmental Protection, water management districts, and health department to determine current irrigation regulations and criteria. Obtain all permits before construction. Abide by all permit conditions and current water restrictions when operating the irrigation system. Obtain any desired regulatory variances before irrigating. Many urban areas use reclaimed wastewater for their irrigation water source. While this offers many benefits, it also can lead to landscaping and pollution problems if not properly managed. Nutrient levels in reclaimed water may vary by a factor of 10 or more, depending on the treatment plant supplying the water. Contact the supplier to get information on nutrient content. When applying fertilizers to a site that irrigates with reclaimed water, consider the amount of nutrients in the water and reduce fertilization appropriately. The application of 1 inch of reclaimed water containing 20 ppm nitrate nitrogen adds about 4.5 pounds of nitrogen per year, pounds of nitrogen per acre, to the soil. If you irrigate 40 inches per year, that accounts to a little over 4 pounds per 1,000 square feet. Reclaimed water may be high in levels of chloride, leading to salt accumulation in the soil. Additional considerations, such as water for flushing salts, may be needed. Nutrient pollution may occur if the user over-irrigates because both reclaimed water that runs on the surface and the water and nutrients that move below the root zone are lost. Maintenance of a high level of distribution uniformity is critical to prevent leaching of these nutrients. Irrigation managers should also pay close attention to all cross-connection controls and backflow prevention devices. All reclaimed water piping, heads, valves, fixtures, etc. are required by law to be color-coded purple and labeled "Do Not Drink." As long as field capacity is not exceeded when irrigating, reclaimed water is a safe and reliable irrigation source. Irrigation system design is a complex issue and should be performed by trained professionals. These professionals should use existing standards and criteria as well as the manufacturer's recommendations to design the most appropriate system for a location. This FDEP publication, Landscape Irrigation and Florida-Friendly Design Standards, lists current standards and criteria. Many communities require construction and design documents and permits that require the signature and seal of a registered design professional. Members of the green industry should be able to visually identify system design problems to help their clients irrigate more efficiently, save water, reduce the need to add fertilizers or other chemical treatments, and improve plant health and water quality. The irrigation design for a site depends on a number of factors, including location, soils, landscape vegetation, water supply, and water quality. An irrigation system needs to be designed to meet a site's peak water requirements. In addition, to prevent irrigation runoff, the system's application rate must not exceed the ability of the soil to absorb and retain the water applied during any one application. The irrigation system should also have enough flexibility to adapt to various water demands and local restrictions. Design operating pressure must not exceed the source pressure. The design operating pressure should account for low pressure during periods of high use, for example mornings, and for project build-out when all of a development's landscaping is in place. Plants should be grouped in irrigation zones based on similar water use requirements. Irrigation systems designed to service both turf and landscape areas should have enough zones to meet each area's individual water needs. In some regions, the irrigation design should account for the extra water required to periodically leach salt buildups that may accumulate due to high chloride levels in some sources of irrigation water. An irrigation system consists of 3 main components: water supply, water conveyance, and a distribution device. The proper design and installation of these components optimizes their use and decreases any off-site impacts. Irrigation design must also account for different site characteristics such as soils and topography. Hand-moved irrigation systems should have enough flexibility to provide sufficient coverage after each move. Microirrigation systems for shrubs and other landscape plants should be designed to cover at least 50% of the root systems. Microirrigation is rarely used for turf in Florida and is prohibited in some places, but if used, should be designed to cover 100% of the grass's root system. To provide for peak water demands and have enough flexibility to reduce supply for different demand requirements, irrigation systems need to be designed with various control devices, rain shutoff devices, and backflow prevention. Water conveyance systems should be designed with devices to protect against blowouts. The water conveyance pipelines should provide the system with the appropriate pressure required for maximum irrigation efficiency, uniformity, and the distribution devices should be designed for optimum uniform coverage. In addition, the distribution system should not include the irrigation of non-planted areas. To ensure optimum uniformity, permanent irrigation sprinklers, spray jets, and other distribution devices should be spaced according to the manufacturer's recommendations. Typically, this spacing is based on average wind conditions and operating pressures during irrigation. If site-specific wind conditions are different than published averages, check with the local UF Extension Office, USDA NRCS, and the Florida Irrigation Society for their recommendations. This table is provided as a general guideline. Spacing should not exceed the percentages provided in the table. After the system is constructed and operating, periodic catch can uniformity tests should be performed. When designed and operated correctly, Microirrigation, also known as drip or low-volume irrigation, is one of the most efficient methods of irrigation. It is highly manageable and provides small quantities of water directly to the plant's root zone. Low-pressure sprinklers, sprayers, and drippers are also known as emitters, and they slowly release water into the soil around a plant. This saves water because only the main feeder roots receive water and less water evaporates from the surface of the soil. Typically, with drip irrigation in a sandy soil, water moves laterally only 10 to 12 inches. Drip irrigation is ideal when such precision is desirable or for narrow strip planting such as hedgerows. Because of the nature and location of drip irrigation, it is difficult to determine if the emitters are providing enough water. Visual inspection of the landscape may identify clogging or excessive watering problems from a drip irrigation system. Overall, spray jets are more desirable than drip emitters for most landscape applications. This is because they cover larger areas and have fewer clogging problems. Clogging and excess water problems can be seen either by careful examination of the irrigation system or by looking at the landscape. Spray jets should not be designed or operated to irrigate non-planted areas. Regardless of the type of microirrigation system, clogging can be a problem if the supply water is not filtered before entering the irrigation system, or if the filtration system is not cleaned. The safest and easiest way to maintain the emitters in a microirrigation system is to keep a small supply of clean backups on hand. Clogged devices can be easily replaced with clean units, then placed in a small container of the cleaning fluid appropriate for the clogging material. Replacement emitters should always have the same operating characteristics, that is, operating pressure and discharge rate, as the original emitters. For more information, see Landscape Irrigation Best Management Practices. Only professionals who are trained, certified, appropriately licensed for irrigation installation by the appropriate agency, bonded, and insured should handle irrigation installation. These individuals must follow the designer's plans and use recognized standards and criteria such as those promulgated by the American Society of Agricultural and Biological Engineers, Florida Irrigation Society, Irrigation Association, U.S. Department of Agricultural Natural Resources Conservation Service, or the manufacturer's recommendations. The designer must approve any changes to the design. To prevent system failures, waste, and property damage, construction materials must meet appropriate standards, such as those from the ASABE, the American Society of Civil Engineers, or the American Society of Testing Materials. Plan all construction practices according to key safety practices. Before construction, the contractor should identify and flag all underground pipes, cables, and other elements. Call before you dig. Call 811 for free Sunshine State 1 call locator service. The contractor should clean the site of any construction materials before the job is complete, and at the end of construction, provide the owner with a copy of the as-built plans, operating manuals, recommended operating schedules for both plant establishment and supplemental irrigation of mature plants, and warranties. For new construction, the job should include a follow-up site visit to reset the controller, a rain shutoff device, and a soil moisture sensor if installed after landscape is established.